video, we will look at the notations used in probability. Say we want to find the probability of getting a head at the throw of a coin. To write this entire thing many times will be very tedious. So using the notation, we can write it as P and head in brackets. It is said as P of head. This is just a shorter way of writing it. How do we write the probability of event A occurring? Simple. It will be P of A. Also, let us try and recall what we looked at in the earlier videos. Independent and mutually exclusive events. What are independent events? They are the events that are just not related. Mutually exclusive? Impossible for them to occur together. Let's erase this and understand something interesting. Sometimes we have to find the probability of events A and B happening together. That is written as probability of A inverted U B. This sign denotes intersection. It tells us that this is events A and B happening together. Other times, we may need to find out the probability of events A or B or both happening together. That is denoted by P of A U B. This U sign means union. Many students feel P of A union B means the probability of just event A occurring or just event B occurring. But remember, it also considers the case of both events occurring together. We really need to understand these two notations in detail. First, let us look at P of A intersection B. Intersection basically means both events happening together. Now give it a thought. When can both events definitely not happen together? When is it impossible? Yes, if they are mutually exclusive. And probability of an impossible event is 0. So this will equal 0 if events A and B are mutually exclusive. Both events cannot occur together. We will look at both these notations in the coming videos. Of the throw of a dice. Assume a fair dice is thrown. Let's think of all the possible outcomes. You may get 1, 2, 3, 4, 5 or 6. These are the only possible outcomes for one throw of a dice. In numerical form, we write it as 1, 2, 3, 4, 5 and 6. Here's the first question. What is the probability of getting a 1? Remember, we need two things to find the probability. First, how many ways in which the event can occur? And second, what are the total possible outcomes? There is only one way in which we can get a 1. That is, if the dice lands a 1. And in all, there are 6 possible outcomes. It means that the probability of getting a 1 at one throw of a dice is 1 by 6. Here's the next question. What's the probability of getting a 3? There is only one way in which we can get a 3, and yes, there are 6 possible outcomes. The probability of getting a 3 is also 1/6. Since the probabilities are the same, we say that these two events are equally likely. Until now, in all the problems we have seen, the numerator has always been 1. When will the numerator not be 1? Let's zoom out a bit to see the next question. What would be the probability of getting an even number at the throw of a dice? Now it gets interesting. We have to look at all possibilities in which we can get an even number. There are 3 ways in which we can get an even number. We may get a 2 or 4 or 6. Yes, at one throw, I will get just one number, not 3. But remember, the numerator tells us the number of ways in which an event can occur. And it can occur in 3 ways. And in all, there are 6 possible outcomes. The number of all possible outcomes for a throw of one dice won't change. It is the numerator that will change in view of what has been asked. So it will equal 3 by 6. This can also be reduced to half, but we keep it at 3 by 6 for now. Let's see one last question related to a throw of a dice. What will be the probability of getting an odd number? 3 outcomes can result in an odd number: 1, 3 or 5. It means that there are only 3 ways in which the dice can land an odd number: either a 1 or a 3 or a 5. And the total possibilities remain 6. The probability will equal 3 by 6. So these two events are also equally likely. It means that if we throw a dice once, the likelihood of getting an even number is the same as the likelihood of getting an odd number. Can you think of an example where two events are not equally likely? We will see that example in the next video. Let's think of a case where two events are not equally likely. Look at this set of numbers: 1, 2, 3, 4, 5, 6 and 7. Assume you have to choose one random number from this set. It can be any one of the 7 numbers. What is the probability of choosing an odd number? To know this, first we need to find the odd numbers in this set. These 4 are odd. You could have picked any of the 4 odd numbers: 1, 3, 5 or 7. And you would have chosen one number from these 7 numbers. So the probability will equal 4 by 7. 4 ways in which we can get an odd number. And 7 is the total possible number of outcomes. Similarly, what would be the probability of choosing an even number? You can choose either a 2 or a 4 or a 6. 3 possibilities out of 7. So the probability would be 3 by 7. So if you observe carefully, the probability of getting an odd number is higher than the probability of getting an even number. In simple words, it means that if you pick any random number from this set, the likelihood of getting an odd number is higher than the likelihood of getting an even number. So these events are not equally likely. 2 more interesting questions and we are done. What would be the probability of getting a 8 if we choose a random number from these 7 numbers? That's weird, huh? Do we see an 8 anywhere in the set? No, 8 is not part of the set. Getting an 8 is impossible because it does not exist in our set. So how many ways in which we can get an 8? Well, there are 0 ways in which we can get an 8. And the total possibilities are still 7. And 0 by 7 is 0. We say that probability is 0 or impossible. And what if you're asked the probability of picking a natural number from these 7 numbers? Any number you pick, it will certainly be a natural number. So there are 7 ways in which we can pick a natural number. And the total possibilities are also 7. And this is 1. We say that the probability is 1 or 100%. We call this a certain event. It will certainly happen. If you watch all the probabilities videos, I would say it is certain that you would master this topic. One interesting concept in this video, and that is a coin toss. You will not believe how interesting it is. Think about it. When you toss a coin, it will either land a head or a tail. Either head or tail. All of us would agree that these are the only 2 possibilities. Suppose I ask you a simple question. What is the probability of the coin landing a head? This question asks us that if we toss a coin, what is the likelihood that the coin lands a head? How do we calculate it? Here's how. There is only one way in which you can get a head. The only way is if it lands a head. That's the first thing we had to find out to find this probability. The second thing we need to find out is the total number of possibilities. In total, there are only 2 possibilities, a head or a tail. This number in the denominator is actually all possibilities. These 2 cover all the possibilities since you cannot possibly get any other outcome. You either get a head or a tail. This tells you that out of the 2 possibilities, there is only one way in which this event can occur. So the probability of a coin landing a head is 1 by 2, which is 1/2. This is a fraction and can also be written in decimal form as 0.5. The numerator tells you the number of ways in which an event can occur, and the denominator is all possible events. Here's another question. What is the probability of a coin landing a tail? The logic is very similar. There is only one way in which we can get a tail, and the total possibilities are just two, head or tail. So the probability of getting a tail is also 1/2. Look at these two events, landing a head and landing a tail. Both have the same probability. And since the probability tells us the likelihood of an event occurring, such events are called equally likely events. We say that getting a head or getting a tail at the toss of a coin are equally likely events. That's because their probability of occurrence is the same. Let's try and deduce a formula for the probability of an event. In the numerator, we have the number of ways in which an event can occur, and in the denominator, we have the total number of possible outcomes. It just means how many possibilities out of the total possibilities. This formula will be a lot clearer as we see more and more examples. The formula is not important. What's important is what we are going to see next. What if there are 10 throws of a single coin? I'm not talking about 10 coins tossed simultaneously. I'm talking about one coin being tossed 10 times. Since the events are equally likely, does that mean that after 10 throws, we will surely get 5 heads and 5 tails? This will not always be true. You may get 6 heads and 4 tails, or maybe 9 heads and a tail, or maybe even 10 tails. So what does this half essentially tell us? It tells us that if the process of tossing a coin is repeated many times, then we will get approximately the same number of heads and tails. So if you toss a fair coin 1,000,000 times, you will see that you would get almost the same number of heads and tails. Remember, the probability does not give you a perfect or a sure shot answer. It just tells you the likelihood of an event occurring. Two coins are tossed together. What is the probability of getting head on one and tail on the other? Head on one and tail on the other. Let's recollect what we did in the previous videos. How many different possibilities exist when two coins are tossed? Head on one and head on the other, head and tail head, tails on both. 4 possibilities in all. In the question, we have been asked the probability of getting a head on one and a tail on the other. There are 2 ways in which this can happen. Head and tail is one and tail and head is the other. So out of 4 possibilities, we have 2 possibilities which satisfy the condition. So we can write the probability of getting a head and a tail as 2/4, which equals half. Do not assume head on one and tail on the other means only this possibility. It hasn't been specified which coin gets a head and which one gets a tail. So we also consider this possibility. Let me modify the question a bit. What is the probability of getting at least one head when 2 coins are tossed simultaneously? We have to look at outcomes where we get at least one head. It means either one head or 2 heads. So the possibilities are head and tail and head. These are the 3 ways in which we can get at least one head. In the 4th possibility, there is no head. So we can write the probability of getting at least one head as 3/4. 3 ways out of a possible 4. There is another way to get the answer. Probability of getting at least one head can also be written as 1 minus probability of getting no heads at all. 1 includes all the possibilities, or you can say maximum probability, and we are just removing the unwanted one, which is why we have the minus sign. Tail and tail is the only case wherein we don't get a head. So it can be written as 1 minus 1/4, which equals 3/4. The answer remains the same, just that we derive the answer a bit differently in this case. This concept, where we remove the unwanted ones from the sample set, is super important and comes in handy when we have many possibilities. Videos, we have looked at probabilities when one coin is tossed. But what if two coins are tossed simultaneously? What are the possible outcomes? Remember, two coins are tossed together. So let's write the outcomes of coin 1 and coin 2. We may get a head on the first one and a head on the other. That's one possibility. We may get a head on one and a tail on the other. That's the second possibility. Or we may get a tail on the first one and head on the second. Or maybe tails on both. Are there any other possibilities? I don't think so. These are the only 4 possibilities when two coins are tossed together. Heads on both, head on one and tail on another, tail on one and head on another, and tails on both. And what we get on each coin is independent of what we get on the other coin. So when you're asked to solve a problem based on two coins being tossed together, you should know that the events of getting something on coin 1 is independent of getting something on coin 2.
No, it is a pack. It is also called a deck, which contains 52 cards, which means that a pack of playing cards will contain 52 cards. The 52 cards are divided into 4 suits. It's 4 different groups. We normally call it as suit, which means that 52 cards in 4 suits, which means that one suit will contain 13 cards. Each suit having separate name and separate symbol. What are those? The first suit, this one, that is called spade. Okay, it is looking like a tree and it is called spade. It is 13 in numbers, so spade is in black color always. The second one is with a heart symbol. It is called heart, so it is also in 13 number. It is always in red color. The next one is that diamond. Diamond is also in red color and it looks like a diamond, and the total number of diamond cards is 13. The fourth one and the last one is called club. Okay, it is also in 13 in number. So what we can conclude, for 52 cards, 4 suits, 13 cards in each suit. So there are total 26 black cards and 26 red cards. Okay, so now we are going in detail into suit. So suit, this is the spade suit. There are 13 cards. I will explain in detail about each suit. So there are 13 cards in each suit. So you can see there is one A, then 2, 3, 4, 5, 6, 7, 8, 9, 10, then J, Q and K. Okay, similarly, and the symbol in spade suit is the spade symbol. Below the letter there is a spade symbol. Okay, so next suit is the heart suit. It is looking the same, but the only difference is the instead of spade symbol it is having the heart symbol. Next is diamond one. It is same, looking same, but the difference is that it is having the diamond instead of spade and heart. The last one is club suit. Okay, now I am going to explain in detail about each suit. Okay, you must understand that each suits are identical, which means that if you know about spade suit, it is applicable to heart suit also. Okay, so this is spade suit. So you can see there are 13 cards, 5 in the first row, second row 5, then last row 3. So the first one, that is, it is written as A, that is called ace. Okay, in each suit there will be one ace, and next 9 cards are numbered from 2 to 10. That is 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, these are number cards. So how many number cards are there in each suit? There are 9 number cards numbered from 2 to 10. Okay, one is not there. Okay, next 3 cards are J, Q and K. J is called Jack. Okay, it is a face card, which means that there is some face in that card, so it is called a face card. Jack. Then next is Q, that is Queen. Queen is also a face card. Then third one is K, King. Okay, so in each suit there will be 9 numbered cards numbered from 2 to 10, and 1 ace card and 3 face cards. Okay, I hope you understand what is meant by a deck of cards, that is 52 numbers. Then we divided that deck of cards into 4 suits, that is spade, heart, then diamond and club. So each suit is having 13 number of cards. 13 number of cards means 9 numbered cards, 1 ace and 3 face cards, that is Jack, Queen and King. Okay, so now we are going to conclude. So there are total 52 number of cards, then total number of red cards, that is 26, and total number of black cards is 26. How 26 came? Because all the heart cards and diamond cards, they are in red color. 13 plus 13, that is 26. Number of black cards, it is total spade card plus total number of that club card, so it is 26. Then number of spades is 13, number of hearts is 13, number of diamonds is 13, and number of clubs is 13. Okay, so each suit contains 1 king card, queen, ace and jack. Okay, each suit contains, so there will be 4 king, 4 queen, 4 ace and 4 jack. Okay, red kings 2. How? Because in heart suit and diamond suit the kings will be in red color, so red kings are 2. Black kings 2, total 4 kings. Same for queen, ace and jack also. Then number of face cards in each suit is 3, so total number of face cards is 4 into 3, that's 12. Means each suit 3, total number of suits is 4, so total number 12. So here is a question for you. A card is drawn from a well shuffled pack of 52 cards. What is the probability of getting a king of red color? I hope you can answer this question. It is a simple basic equation of probability, number of chances of getting a king of red color divided by total number of chances. If you can solve this problem, you can solve it and comment your answer on the comment box. Anyway, I am going to explain the problems of probability of cards in coming lectures in detail for easy understanding of you. So thank you for watching. You can watch lecture number 6, that is the coming lecture, and thank you for watching. Thank you.
Thank you for watching our channel. This video உங்களுக்கு பிடிச்சிருந்ததுனா கமெண்ட் பண்ணுங்க, லைக் பண்ணுங்க, ஷேர் பண்ணுங்க. மறக்காம இந்த சேனலை சப்ஸ்கிரைப் பண்ணிட்டு பக்கத்துல இருக்க பெல்